Hi there, and welcome to this video about the Laplace transform. Well, welcome back if you are have been watching the channel, and just welcome if you never watched it. Anyway, we're going to start with the Laplace transform of f of t equal to 1. If you don't know what a transform is, not just the Laplace transform, but a transform in general, and why we bother with transform, well, think about circuits and circuit analysis. Whenever you have to solve a circuit and deal with a circuit, you may have a circuit that does any kind of stuff, and it's yeah, we can actually use differential equations and so on, but sometimes it's just very complicated. It gets overcomplicated. So it's actually easier to deal with the circuit in the time domain. And to do that, we use, well, you can use Heaviside operators and operators in general, but most of the time we use the Laplace transform, which is a particular case of an operator. There is also the Fourier transform, which is a particular case of the Laplace transform, but I'm not going to cover any of this in this video. I'm just going to show you how to compute a Laplace transform of a function. And I'm going to start with a very simple function. So as a simple function, we're going to find the Laplace transform of f of t equal to 1. So our function of time is equal to 1. So very simple. So how do we do that? Well, Laplace transform of 1, f of t equal to 1, I'm not going to write it again. So if we do that, well, first, we're just going to apply the definition of the Laplace transform. So what's the definition of the Laplace transform? Well, the definition is the integral from 0 to infinity of e to the negative st. You're gonna have to memorize this, and it's gonna become your best friend. Like, whenever you go to bed, that you gotta think about something before going to bed. Eventually, you're gonna think about the integral from 0 to infinity of e to the negative st. You're gonna have nightmare about it. No, just it's gonna be your best friend within the next few years. So the integral from 0 to infinity of e to the negative st, but now we are actually trying to find the Laplace transform of this function. So we do times our function, so times 1. Now, in dt, of course. Now, let's just do this very hard multiplication. So we just get the integral from 0 to infinity of e to the negative st in dt. Now, what you are going to do is to find the limit as n approaches positive infinity of this whole thing, but by swapping infinity with n. So the integral from 0 to n of e to the negative st dt. So in order to solve this limit, we gotta solve this integral first. How do we do that? Well, it's actually easy. This is where your calculus class, all you have studied in your calculus 1 class, comes together. Well, calculus 1 and 2 and 3 and so on, but well, essentially this is just calculus 1 things. So we're gonna have the limit from n to positive, approaching positive infinity of this integral. Well, this integral is actually, well, e to the negative st is just 1 over, we have a negative s, so 1 over negative s times this whole e. So if you remember the integral, how to solve the integral of e to the something, just like this, even in this case. So you have 1 over negative s, because we have a negative here, times e to the negative st. So this whole thing here. Well, evaluated between 0 and n. Now, let's just put 0 and n back into our result from this integral. So this is the limit n approaches positive infinity of, oh, well, I'm gonna need this bracket here. So this is actually, well, I'm just gonna rewrite this as negative in front of everything. So it's negative 1 over s times e to the negative s times, we're gonna swap t with n first, so s times n minus, we're gonna have the same thing, so negative 1 over s e to the negative s times, and we're gonna put 0 here, so s times 0. There we go. Let's go on. So this is the limit, then approaches positive infinity of this whole thing. So this is gonna stay the same. It's gonna be negative 1 over s e to the negative s times n minus, and we're just gonna multiply this by 0, so this is actually negative 1 over s e to negative s times 0, just e to the 0. If you remember, e to the 0, it's just gonna be 1. It behaves just like any other number in this case. So, so this is the limit as n approaches positive infinity of negative 1 over s e to the negative s times n minus 1 over minus 1 over s, so minus becomes a plus 1 over s times 1, just 1. Yeah, I'm just gonna write it, prefer to say times 1, and just gonna be 1 over s. So this is the limit as n approaches positive infinity of, well, negative 1 over s e to the negative s times n plus 1 over s. Now, it's not over yet because we still have to compute the limit. But actually, we do know how to compute the limit, because we just have a limit for n approaching infinity, positive infinity, and this is negative 1 over s times, and this is a plus. So I can just say, okay, I'm just gonna get rid of this and bring this out on the left hand side. I'm just gonna not care about this plus 1 over s because it doesn't have any term with the n, so it's essentially not a limit. So if I do that, I get that negative 1 over s times the limit as n approaches positive infinity of e to the negative s times n plus 1 over s. So now we're here. What do we do? Well, we can say, okay, I'm just gonna define, because if we just at this point if we just say, okay, we have this n here, we just replace this positive infinity with n, we will have a number, so e, which is basically essentially a number, raised to the negative s times infinity. No, that's not actually good. It's not, everything is gonna go to, is not what we want. So how do we solve this? Well, we can say, okay, we define g of n as negative s times n and f of u as e to the u. Okay, so this whole thing becomes e to the u, and g of n is this thing, so negative s times n. Now, in this case, the limit as n approaches positive infinity of negative s times n, well, we can do the same thing, so as a multiplication, so negative s times the limit, we'll have negative s times the limit as n approaches positive infinity of n, okay, which is just, negative s times positive infinity, which becomes negative infinity. Now, in order for this to be right, we gotta say, okay, we're gonna assume that s is greater than 0. Because otherwise, this whole thing, well, this thing, if it's gonna be 0, it will be, infinity times 0. That's not good either. And if it's negative, it will be positive infinity, which is not good either. So once we have done that, we can say that the limit as u approaches negative infinity of e to the u is actually, well, the result we have got here. So it's just e to the negative infinity. But negative infinity, what's that? Oh, negative infinity is something weird. No, it's not. It just behaves like any other number. So what do we do when a number is raised to the negative value? Well, it just means that this is 1 over e to the infinity. But e to the infinity is a very, very, very big number. So this one essentially is infinity. So 1 over a very, very big number just is 0. This whole thing. So this whole thing is 0. Now, if we go back and bring these results we have just found back here, we're gonna find that, well, these things, so negative, so in the end, we're gonna know that negative 1 over s, negative 1 over s times our limit we just solved is 0, so times 0 plus 1 over s, plus 1 over s. So 1 over s times 0 is just going to be, 0 plus 1 over s. Therefore, our final result is 1 over s. Is it over? No. We're going to, well, it is over, but it's very, very important that we say with s greater than 0. Because we assumed that here when we said, okay, this is negative infinity, but note that we're gonna specify that s is greater than 0, otherwise none of this is gonna work. So yeah, this is the Laplace transform of f of t equal to 1. So the Laplace transform of 1 is 1 over s with s greater than 0. And that's pretty much it.